Hello my friends of Qatari Labs, my name is Saul Montoya. Welcome to this tutorial. This tutorial is a tutorial of groundwater modeling with regional flow, a river and a lake and theory piezometers. Okay, this tutorial is in fact the basis of a coming webinar, and the webinar is about a sensibility analysis of Modflow models but with Python and the Salib library. Okay, so this, if you were aware of the software of the Ucode and PEST, those are software that can do sensibility analysis and automatic parameterization. But for us, with this, well, we see that there was a lot of process involved, and maybe the software was not so user friendly. So we came up with a method of how to do a sensibility analysis with just a Python library. Okay, or with the of the groundwater flow model imported with Flopy and then running a sensibility analysis. So, but this will be part of the webinar. But in this case, we are going to do the model that will be a basis for the sensibility analysis. Okay, so let's start. Okay. So here you will receive in the description of this video these folders. Okay, you will receive model and shape files. They're the most important. Okay, so let's start with a Modflow model Muse. Sorry. Model Muse. Acá, create new Modflow model. Next, Modflow 6, 3 layers, no grid. Okay, no grid, remember. Oh, sorry. No grid. Okay, great. So let's start by importing our area of study. File, import shapefile. Then model, sensibility analysis, shape, and then this will be model grid. This is my shapefile. Cell value of enclosed cells 0. That's it, nothing else. Okay, nothing. Okay, it appears here, but I can go as well with this option, show or hide objects, and then here I double click here, and then I say that I want to use this to generate the grid cell, the grid of 50 meters as the grid cell size, and a change of color, why not? Okay, nothing else, close, and then I generate my grid, okay, and this is my grid. You got it. Okay, great. Then what else do I need? I need to import the elevation. File, import shapefile, model elevation, set value of intersected cells, single multipart object, 0 formulas set, offset, 0 set formulas, model top. Just do a click outside this word, because otherwise the checkbox do not appear, and then do a click here, and then we are going to import this directly to model top. Remember that it has to be the set values of cell by interpolation has also to be active. Okay, otherwise it will only apply to the intersected. Okay, so here model top, and the interpolation will be fitted surface. Okay, fitted surface, and then this one. Okay, and then I said okay, and this is my surface elevation, and then as you have seen, it has already applied. Oh, sorry, it has already applied on the to the model, believe me. Okay, so because, oops, I think I have some, it has already applied to the model because it's here, if you see, it has, it's here. Okay, so let's continue. What else? Let me arrange this because I could be missing some details. This might be, okay, great. So this is okay. So it's already here. Okay, so let's continue. What else do I need? Okay, I need to go to data, edit data sets. Here on required, I need to go to is active, and here on KX I have to apply a formula. Data sets, and this will be case. This is a conditional, this is like a switch or like a leaf layer for n times to the minus 4, 5 n times to the minus 5 to n times to the minus 4. Okay, so 4, 5, and 2. Yeah. Okay, and this apply again, and then let's check that if already this is on KX. Okay, then Modflow initial head is model top. Model top. Initial head is model top, and KX is this one. Okay, here in layer definition, the lower aquifer bottom is 0. The middle aquifer bottom, we go to edit formula, and this is lower aquifer bottom plus 0.33 times model top minus lower aquifer bottom. Okay, then you will understand the arithmetic of this has a simple logic. I use it in most of my tutorials, so I leave you this as homework. Okay, and here it will be 0.66. It, in fact, that creates some parallel layers. Okay, great. So you have already the hydraulic parameters, and then you have the geometry. Let's go for the boundary conditions and the observation package. Okay, I will change color of my contour line, so because I don't like this color. Okay, great. So let's go to model, Modflow package and programs. Okay, in flow package, MPF is okay. Boundary conditions, recharge, general head boundary, and river. These 3 boundary conditions. Okay, solvers, the same, we don't require anything else, and observation will be ops. Okay. Okay. Object, hide all objects. Okay, so let's start implementing our boundary conditions. File in, okay, I have to check if I turn it observation. Yeah, observation is also file, import shapefile, file, import shapefile, and then here I will select regional flow, set value of intersected cells, set formula will be 32. Nothing else. Okay, so yes, intersected and 32. Okay, here double click and then object, change of color, and then go to Modflow features, GHB -10, boundary height is 32, and the boundary, the conductance, because the conductance will be a part of the sensibility analysis, so we need to specify to set a specific value of conductance, because otherwise the software will interpret the conductance by the length of the shapefile inside the cell or something like that. So let's better if we specify a value of conductance, and the value of conductance will be 0.03. Okay, great. Okay, great. Then file, import shapefile, and then let's go start with the lake. Set value of enclosed cells 1, and the lake is at elevation 29.5. Okay, and what else? 29.5. Modflow features. Okay, let's type OK. Double click. Change of color. And then GHB. Yeah, it's a GHB -10. The boundary height is 29.5, and this is direct 0.002. Okay, that's it. Then start with the river. The river, set value of intersected cells, single multipart, no, separate object. The river is single multipart object. Formulas, set formulas is, here is 29.5. Okay, great. Then double click again, change of color. Yep. And here is river -10. River stage is 29.5. 29.5. Conductance is 0.005, and the river bottom is 28.5. This is direct. Okay, that's it. Okay, ready. So we have already the hydraulic parameters, we have the elevation, the geometry, the boundary conditions. We need to set up the piezometers and the recharge. There are the two things that are missing. So let's start with the piezometers. Import, check file, model hop, and this will be separate objects, set value of intersected cells, nothing else. Okay, yeah. So let's edit the piezometers one each time. Double click here. Model hop 3. It will be, the screen will be at 24 meters. Change color. It will be observation. It will be called piezo 1, and it will have a head observation. Okay. Then, okay, let's start with the one that is in the center. So this one, double click. It will be this one. It will be, the screen elevation will be at 20, and it will be called ops, and this will be called piezo 3. Let me review if this one, because if this is not activated, actually it doesn't do nothing. I mean, it won't work as a piezometer. Okay, so it's working. And then here I will change the color because I'm using red for my piezometers. And then I select this one, the last one. This will be piezo 2. Oops. Piezo 2. Okay, great. So this will be 24. And here it will be ops. And this will be called piezo 2. And it will be a head observation. Nothing else. Okay, that's great. So this is the tier piezometers are already set up, and then I create a rectangular object to represent the recharge that covers the whole extension of my model, and then say recharge, model recharge, and then here it will be 0 formulas, set values in closed cells, change color. Okay, then Modflow features, recharge, -0, 0, and this will, how will we be called? (3.16) 10 to the -9, that is around 100 millimeters per year. Around, I guess. Okay. Okay, great. So save your project. So go to model, and then call it model 1. Okay, then run your num file. This will appear. It has rich convergence. That's great. And see the water budget. The water budget has to be really similar of a previous model, because that for the next part, I mean for the webinar, it's really important that we have constructed well this in order to make the sensibility analysis. So I'm going to compare this to another yeah, this is from my, how I say, blueprint, my original model. So yeah, we are really close. It's not exactly the same, but we are really close to the water balance. Yeah. Okay, and let's see the heads. Let's see the heads of this model. These are here on model, and these are the heads. Okay, look, here I only have piezo 2 and piezo 1. What does it mean that piezo 3 is not activated? Let's activate this. Okay, select this, right click, hide selected object, and then which is piezo 3? This is piezo 3, and then I have to select this. I told you, if you don't select this, the piezometer won't generate any output. Okay, once again I save it and then I run it. Result, the water balance will be the same. Interesting. Yeah, will be almost the same, but if we go to the sensibility analysis, if we go to the here we have the piezo 1, the piezo 2, and the piezo 3. Okay, if this is the some like the code, and this code is actually, if you see this 30.09, this is generated by the function. I mean, we define the model as a function. No, we define the model as an object. Okay, so it has to be similar. 30.099, 30.090, 30.200. Okay, yeah, it's really close. Yeah, so that means that this model is in really shape to do the next part, that is the sensibility analysis. I hope that this tutorial will be helpful for you, and I invite you to the webinar on sensibility analysis, because the process is much more simpler, because we use standard Python. Yeah, if you know Python, you will find it really simple, really easy to do outputs, to do sensibility matrix, and let's see if in the future we can do some automatic parameterization with the scikit, with neural networks, because I guess that we can do that as well. Okay, so far, and that was the tutorial. You can, if you are not going, or you're not willing to do the webinar, you can import the heads. Okay, and these are the heads on the model extension. Let me. Okay, so this is the head distribution that goes from the region of flow, goes to the lake and to the river, and these are the 3 piezometers. So far, this is the tutorial. I hope that it was helpful for you, and it was entertaining, and it was of quality. So if you have any further questions, like it was not really your case, but to discuss more about the software, yeah, you can contact us by our social networks, and hope that we can provide you more tutorials in the future, and webinars and other events. And thank you for following us. Give it a like to the video, subscribe if you want, and hope to see you in coming tutorials. Bye bye.